We'll proceed in the product rule in differential calculus. Why calculus? Why calculus? How calculus? Why calculus? How calculus? Why calculus? Because we need to compute the net collection. If I have rate of collection, if I have rate of collection, then from rate of collection, how I can compute the net collection. So one way that is that you, whatever the rate of collection is, then transform into algebraic equation and then draw algebraic equation as per the independent and dependent component and get the area. If you get the area where the y-axis is rate of collection, x-axis is on which rate of collection, that is independent component, x component being independent component and y component being dependent component, then y equal to fx. Y equal to fx. If I have x-axis, if I have y-axis, if I have x-axis, if I have y-axis, if I have rate of collection. I have always given example like a person is walking at 3 km per hour. He is collecting 3 km per hour. Hour is independent component as per the algebraic calculus. So if I draw x-axis and that is hour and y-axis being rate of collection, that is 3 km per hour. It is a constant line that is parallel to the x-axis at height 3 km. How much he has collected between 0 time to any time x, that is the area of this graph. If this is x-axis, this is y-axis, and this is the graph, what is the area underneath the graph is the integral calculus. Just calculate the area, that is integral calculus. But it is simple when it is a straight line, and calculating the area is nothing but calculating the rectangle's area, width into height. If he has to find, someone has to find how much distance he has collected up till x kilometer, x into 3, 3x. 3x nothing but area of a rectangle also, where two sides are x and 3. Okay, so what is fx? What is function over x? That is 3, or 3 into x to the power 0. If it is x to the power n, then area is x to the power n plus 1 divided by n plus 1. If I have a function fx, if I calculate area of fx, fx is algebraic equation, area gives another algebraic equation gx. If I do anti-integration, then gx to fx back. This anti-integration is called derivation. Or if gx to fx is derivation, then fx to gx is anti-derivative. Or if fx to gx is integration, then it is anti-integration. So this way we can kind of proceed. There are many ways we can proceed in calculating the integration. One way is calculating the area from fx to gx. Other way is that whatever algebraic equation you have, then transform into a smaller algebraic equation which you know the integration for. If that is the case, then again you can calculate integration of fx to gx, because whatever fx is there, break into smaller part, and a smaller part integration you know. Or if you know differentiation of gx back to fx, then fx integration is gx. How you can calculate is first principle. If you have gx, then gx plus delta x minus gx by delta x, or gx plus delta x minus gx minus delta x by 2 delta x. So there are three ways that integration can be calculated. One way is, if fx is there, calculate the area. Second is fx break into smaller part, and for a smaller part you know the integration. Then also you can proceed. Or if you have gx, any gx for which differentiation is fx, then fx integration is gx. Three way you can calculate the integration. Now question arises is, what is the integration of multiplication. If I have two functions fx and hx, fx into hx. If I have two functions fx into hx, what is integration of fx into hx? If I know integration of fx and hx both, what is integration of fx into hx? What is integration of sine square x? Sine x into sine x. Fx is sine x and hx is sine x. What is integration of fx into hx? That is called product rule in integration, integration by part, or chain rule in integration. I don't know. What about chain rule in what? Okay, that is called chain rule product rule or integration by part. We can consider this one, product rule or integration by part. What about integration by part or product rule in differentiation? If I don't know this way, can we calculate this way so that this way we can calculate? So if I have a function gx into hx, function is gx into hx. What is differentiation of gx into hx? I know differentiation of gx. I know differentiation of hx. What is differentiation of sine square x? Sine x into sine x. Okay. What is differentiation of gx into hx? That is the question. The first thing what we saw, if I want differentiation of gx into hx, then gx into hx, if there are two multiplication of two items, then two items can be considered as sides of a rectangle. This is what we have seen, but there is a locha in this concept. If this is gx and this is hx, this is hx and this is gx, multiplication of gx and hx gives the area of rectangle. So if I have area of rectangle, that is gx into hx, this proves that gx is one side and hx is one side. So if I want derivation of gx into hx, then we are trying to get the derivation of this area. If I want get derivation of this area, whatever comes, consider the dg. We are trying to get the gradient of gx into hx, derivative of gx into hx, differentiation of gx into hx. If I want differentiation of gx into hx, derivative of gx into hx, okay, gradient of gx into hx, consider that has some result. If that has some result, then it has two shares. One share is gradient of gx separate and one share is gradient of hx. If this is gx, if this is gx, then this is considered gradient of gx. If this is fx, then consider this is gradient of fx, dfx by dx, dgx by dx. If this goes through and this goes through, then it will form a corner because area increase like this and area increase that like this. There is a corner that is formed whose dimension is dgx by dx into dfx by dx, whereas increment in this area dgx hx by dx, if this differentiation has some value, that is nothing but if gx into hx is area, if gx into hx is area, then its differentiation is small area. Dgx into hx by dx is nothing but if I increase 1 unit of change in x, then how many unit of change we can see in gx into hx, that will come as area, meter square. For this area, if that is a meter square, then in that meter square, what is the contribution of gradient of gx and what is the contribution of gradient of hx? If this is the contribution of gx in delta A we are calculating, and this is contribution along the fx, then this area what we are seeing is gx into dfx by dx. This area is fx, sorry, this is hx. We are calculating differentiation of gx, hx. this is hx, this is hx, and this is gx. If this differentiation brings delta in multiplication of gx and hx, then that delta will have share for the gradient of gx also, gradient of hx also. Consider this is the gradient of gx, that gx had the share. This is gradient of hx, that hx has the share. Then this area is gx into gradient of hx. This area is hx into gradient of gx. So this area plus this area, that is dgx hx, is nothing but gx into dhx by dx plus hx dgx by dx. There is this corner area that is remaining is dgx by dx into dhx by dx. Since they are very small, we can consider at 0. So integration by differentiation of the product rule, where gx and hx two functions are there, their multiplication is gx dhx by x plus hx dgx by dx. Okay, plus dgx by x into dhx by x. That I consider as 0 when delta gx and delta hx tends to 0 or delta x tends to 0. This is what is not digestible to us. So what we consider here is, rather than doing the differentiation of gx and hx, doing the differentiation of gx and hx, doing the differentiation of gx into hx, where we say that whatever is the differential value is, it has share for the gx gradient and hx gradient. Let's consider gx into hx is area ax. ax. If I differentiate ax, then there will be delta A. Delta A has two parts. One is delta A1 and delta A2. Delta A1 is nothing but area, the delta area which is along the gx, and delta A2 is the area which is along hx. If this is hx, then area along hx is this one. If this is gx, then area along gx is this one. If this is a1 and this is e2, this a1 is nothing but gx into whatever the gradient, since it is a gradient, whatever gradient we receive through fx. So gx into gradient of fx, a gradient of hx, this is hx, gx into gradient of hx, hx into gradient of gx. If gx, then this area is hx into gradient of gx. So this will become that dgx into hx by dx equal to dax by dx equal to delta a equal to delta a1 plus delta a2 equal to delta a1 along gx plus delta a2 along hx equal to gx dhx by x plus hx dgx by dx. Both has demerit. Both has second what we have proposed, the second one we have proposed. But here someone will say that why, how it is a1 plus a2. And in first principle, someone would say why I consider this corner area as 0. Why I should consider, even it is infinitesimal small, then it has some amount, and that some amount you are losing when you are saying the dx into hx derivation is gx dhx by dx plus hx dgx by dx. Okay, so we are calculating how calculus. How calculus means how I can develop the calculus formula. So when we know basic building blocks like what is integration and differentiation of polynomial equation, what is integration and differentiation of trigonometrical equation, sin x, cos x, tan x, what is the integral and differential for the exponential, logarithmic, and so many, then what is the integration of the product. Then we are going by other way, what is the differentiation of the product. So looks like differentiation of the product of the fx into hx is gx into hx is gx dhx by dx plus hx dgx by dx. If I take through first principle, then it is gx plus delta x into hx plus delta x minus gx hx divided by delta x. We can introduce here, in this equation, we can introduce gx plus delta x hx minus gx plus delta x hx. We can just introduce this term. Now this will become gx plus delta x, and in bracket hx plus delta x minus hx plus in another plus plus hx plus delta x in bracket gx plus delta x minus gx whole divided by delta x. Then it will turn into gx plus delta x into h plus delta x minus hx divided by delta x plus hx gx plus delta x minus gx divided by delta x. It will become gx plus delta x gradient of hx plus hx g gradient of gx. Everything is fine, but one term is g plus gx plus delta x. If delta x tends to 0, then gx plus delta x becomes gx. Again, not acceptable. Approximation is not acceptable. You can remove the approximation. Like, what is differentiation of x square? Differentiation of x square, that is x plus delta x whole square minus x minus delta x whole square divided by 2 delta x. Then full will become 4x delta x divided by 2 delta x. Then it will become 2x. This is acceptable, where we are not approximating delta x as 0, it is going away. But here, if I trying to find the differentiation of gx into hx, then it becomes gx plus delta x gradient of hx plus hx gradient of gx. Gx plus delta x, where delta x tends to 0, it becomes gx, not acceptable. Okay, then through area way, not acceptable. Through first principle, not acceptable. Whatever we have proposed, go through area way. Consider gx into hx as area. Now you are doing dax by dx equal to delta a equal to delta a1 plus delta a2 equal to delta a1 along gx plus delta a2 along hx. And then you have two area only, and then you get the product rule, where a traditional way is differentiation of gx and hx brings a share in gradient of hx and gradient of gx, and then you have one strip along gx one strip, and along hx one strip, and you get extra strip. Okay, so that is the concept of the product rule. Now we went with the other way. This is our way. The area way was our way. This is also our way. Oh, if this is x-axis, and consider there is a line like this. What is the equation of line? What is the equation? Equation means if I keep changing the x value, I get the y value. That is called equation of the line. If this is x-axis, this is the equation of line, then what is equation of line? Equation of line is nothing but what is the slope of this line? Slope means y by x. If I change 1 unit of x, then how many of unit change seen in the y? Consider it is 2. If I change 1 unit along x-axis, it will change 2 unit along y-axis. For every 1 unit change, I can see 2 unit change along y-axis. Y by x is 2. Then equation of the line is y equal to y equal to 2 into x. Y equal to slope whatever slope we are talking about 2, y equal to 2 into x. What we consider the slope, it was a straight line. Consider this is not a straight line, and this is something like this. If this is not a straight line, then it is something like this. Then what is the slope? Slope at every moment is different. Here slope is like this, then slope is like this, slope is like this. So every moment slope is different. Rather than saying slope is y by x, I will say slope is dy by dx at any point x, x equal to x0, x1, x2. So what is the equation of this? So what is the equation of a line at any point? What is the equation of line? Means what is the equation of the tangent, slope tangent at any moment, straight line. If I had a straight line, if I had a straight line, then this straight line, whatever the slope is, then slope is the tangent is along the straight line. So we can get the formula of the straight line straightforward. But if I have a line that is a curve, then at each point, then whatever the tangent is, the tangent equation I can get what is the slope of the tangent, that is dy by dx. The tangent line is y equal to dy by dx into x. We can get it. What is y in 2D plane? Y equal to dy by dx into x. What is fx? Fx equal to dfx by dx into x. Okay, we learned it. If I have to draw the line equation, then line equation is nothing but y equal to dy by dx into x. If it is a straight line I have to find, then dy by dx will be some scalar into x. For a curve line, if it is a curve line, and then I have to find the equation of a line, then which line? That line is a tangent line. Then every moment, whatever the tangent is, what is the equation of that line? Tangent will have a slope. That slope is dy by dx. If this equation is y, the dy by dx at that point, and then y equal to dy by dx into x. That is the equation of this tangent line. What is the equation of a surface? If equation of a line is dy by dx into x, then what is the equation of a surface? What is the surface? Consider this is xy plane. Consider this xy plane. Consider this is x-axis. Consider this is y-axis. Consider this is x-axis and this is y-axis. It looks like this. Okay, if that is the case, then there is a plane that is kept on the xy plane. Plane height is 0. Okay, what is the equation of if I rotate this plane along in kind of x-axis? Okay, where this y-axis is constant. Okay, now any point, there is no one point, there is no one coordinate. So if I consider this as xy plane, consider this as xy plane. If this is xy plane or whatever we were doing, so consider this is xy plane. If this is xy plane, then there are many points on the xy plane. Each point is called x comma y, or x1 y1 x0 y0 x2 y2 x3 y3 x4 y4. There are so many points. If there are so many points, then for this point in xy plane, if I have a function fxy, then what is fxy? Fxy is nothing but a value on the vertical side, that is z. Z equal to fxy. If I have a 2D where independent component is x-axis and dependent component is y-axis, then y equal to fx. For each point on x, there is a point on y. If I connect all these points, it becomes a curve. Like that, if I have two independent components, x and y, and x and y lie on xy plane. If x and y lie on xy plane, then for any point x comma y, there is a z value. There, any point x, there was a y value. This z value is function over x comma y, where x and y are two independent components. Or we can say there is single independent component, that is xy plane. For each point on the single independent component, we have dependent component is fxy or z. So whatever the fxy algebraic equation is, as per the algebraic equation, we will get the z value. So if this is x-axis and this is y-axis, for each x comma y, I will push in the Python function f, where x and y is parameter, and it does some computation and returns the z value, that is fxy. It is literally fxy. If you call f with xy as parameter, that is function over x comma y, or xy plane. If that is the case, then z is function over x comma y. Okay, so what is the equation of z? Earlier in 2D, where x and fx was there, then equation of the fx was dfxy dx into x. If I have independent component as xy plane or x-axis and y-axis, what is fxy? Then it looks like fxy equal to dfxy by dx into x plus dfxy by dy into y. This is Taylor polynomial approximation first order. If I have any function as fxy, if I have any function as fxy, is approximates Taylor polynomial approximation as first order is dfxy by dx into x plus dfxy by dy into y. This is the first order Taylor approximation of any function fxy. Okay, if that is the case, but we can prove it. Literally, we proved it, right? If I have a line, if I want to get the equation of the line, if I know the slope of the line, that is y by x, then slope into x will give me instantly what is the y. If slope is 2, then for any value x is alpha, then 2 into alpha is the y. That is the equation of the line. Y equal to 2x. Y equal to dy by dx into x. Now consider this is xy plane, this is xy plane, and the surface is kept on the xy plane, where the z is 0 always, fxy equal to 0. Now keeping the y-axis constant, surface at y-axis, now I tilted x-axis. Now this is xy plane. Any point on the xy plane, that is x0, y0. There is a point called x0, y0. Or better to understand, it is not at the origin. Then there is a point called x1, y1. There is a point on the xy plane, x1, y1. Okay. If this length belongs to x1, if this is x-axis, this is y-axis, and this is kept on the xy plane, now there is a tilt like this, then consider this is xy, x1, y1 point, x1, y1 point on the xy plane somewhere. Then this is x1 and this is y1, somewhere it is there. Then how much is the z we have got? The z what we have got is dz by dx, that is the slope, into x1. How much z we have got at point x1, y1? If I keep y as constant and tilt like this, then what is dz by dx into x1? Dz by dx at x equal to x1 into x1, that much z we have got. We got z at point x1, y1. At every x1, y1, z is different. At origin, there is no z. But as we move along x-axis in xy plane, z is higher. For smaller x, z is small. For bigger x, z is bigger. For higher x, z is higher. What is the equation of z in this case? dz by dx into x. So if there is a point x1, y1, z is this high. Now keep the x-axis constant and tilt y-axis. Z is even higher. Can you see? Earlier, z was this high. Now z is this high. What height got added? Consider this is, now I kept x as constant and only tilt the y. Then what is z? X, okay, x I am keeping constant. There is no movement in the x-axis. and tilt only y. If you tilt the y, or from my side, if this is x-axis, I am keeping x constant and tilt the y, how much z we are getting? Dz by dy into y. If I tilt, if I tilt only y and then tilt x, then how much the height we get? First we get by tilting the y, and then that is dz by dy into y. Then we got tilting the x, keeping y constant, then dz by dx into x. So net z we get is dz by dx into x plus dz by dy into y. This is proved through Taylor series also. This is first order polynomial approximation of any function fxy, that is dfx by y dx into x plus dfxy by dy into y. That is nothing but slope along x-axis and then multiplying by x, and then slope along y-axis and multiplying by y. If that is the case, then fxy or z equal to dz by dx into x plus dz by dy into y. This is our proof. It is not available anywhere else. Now consider fxy, consider x as gx and y as hx, or consider x as u and y, x as u and y as v. So we are trying to get function over x and y, function over x and y, function over x and y. Okay, function over function over function over x and y, fxy. Consider function over x and y is x into y. Function over x and y equal to x into y. Okay. Consider x as u and y as v. Then function over x and y is u into v. If that is the case, z equal to fxy, z equal to u into v. You consider u as ux, function over x, and v as function over x, ux vx, or fxy equal to x into y, fxy equal to x into y. Consider x as u and y as v. fxy equal to u into v. fxy equal to dfx by dx into x plus dfxy by dy into y. fxy equal to z equal to dz by dx x plus dz by dy into y. What about gradient of this line, this equation? Z equal to dz by dx into x plus dz by dy into y. If that is the case, the gradient is delta z delta z. Delta z equal to dz by dx into delta x plus dz by dy into delta y. So gradient of equation what we drew, z equal to dz by dx into x plus dz by dy into y, becomes delta z equal to dz by dx delta x plus dz by dy delta y. If that is the case, then z equal to u into v, where u is x in our equation and v is y. So delta z means gradient of u into v. This is what we want. Gradient of u into v equal to dz by dx. Z equal to u into v. D of u into v by d u into u plus into d u into gradient of u. Dz by dx, x is u, du into v by du into du by dx, or gradient of u, plus dz by dy, d of u into v by dv into delta y. Delta y is nothing but dv, gradient of v. So gradient of u into v, gradient of z, delta z, gradient of z is gradient of u into v. This is what we want. Equal to mind it, dz by dx, d of u into v by du, partial derivative of u into v by u. This is the biggest term here. Partial derivative of u into v with respect to u into gradient of u plus partial derivative of u into v with v into gradient of v. Then gradient of u into v, that is z, equal to gradient partial derivative of u into v with u is v. V into gradient of u plus u into gradient of v. So gradient of u into v equal to gradient of equal to du into v by du, partial derivative of u into v by with respect to u is v into gradient of u plus u into gradient of v. We proved it. So this is the product rule. This is the most powerful proof of the product rule in differentiation. The gradient of or differentiation of u into v is nothing but v into gradient of u plus u into gradient of v. Mind blowing, right? So this is what is the gradient of u into v. We proved it through very simple straight line equation or state surface basic equation only. Please support us. Okay, you can let us know if you want to support us, if you are capable. If you are capable, then support us. Our number is +91, that is India code, and then 94831 60610 +91 94831 60610. So this is country code of India +91. Please support us. So product rule of differentiation can be achieved through first order Taylor polynomial series of any function fxy or through simple equation of a surface. What are the other proof that we can achieve? What are the other proof that we can go with the product rule? Other proof are, we will go with a simple polynomial equation that is also powerful. If I have equation x square, the derivative of x square is 2x. This is also a proof. That through that also we will prove the derivative of u into v is u gradient of v plus v gradient of u, or through logarithmic. If I have u into v, then natural log ln of u into v is ln u plus ln v. Through that way also we can calculate the product rule differentiation. Then from product rule of differentiation we will go product rule of the integration, that is the target, or integration by part. Okay, so that we will see.